We have a chart with two functions, capital F of x and capital G of x. We're going to figure out whether they represent linear or exponential functions. Linear functions means we're adding the same number each time. Exponential functions mean we're multiplying by the same number each time. So first, looking at F of x, we want to figure out, is it linear or exponential? So to figure out if it's linear, I'm going to subtract two consecutive numbers. So looking at these two numbers here, for the y values, I'm going to do 2.64 minus 1.32. And the difference there is 1.32. So I want to check, can I just keep adding that amount and see if it works? So I'm going to check, I'm going to add 1.32. And that gets me to 2.64. If we do that again, if we do 2.64 plus 1.32, does it get us 5.28? If it does, we have a linear pattern. If it doesn't, it's not linear. So 2.64 plus 1.32 is not 5.28. So if we think about that difference, 5.28, the next two consecutive numbers minus 2.64 is 2.64. We can't get the same difference for each one. So they're not the same, it's not linear. We can't just keep adding 1.32, that is not the pattern. So let's see if it's exponential by seeing if they have their same ratio. So I'm going to do 2.64 and divide that by 1.32. I'll do that in my calculator and I get 2. So I want to see this option. If I multiply by 2, I get from 1.32 to 2.64. What if we multiply by 2 again? Does that get us to 5.28? So 2.64 times 2 is 5.28. I'm going to try it again. Times 2. 5.28 times 2 is 10.56. I'm going to try that pattern again. Times 2, I really do get 21.12. So this pattern here is that we times by 2 each time. So since we have our factor, if we're multiplying by 2, this must be an exponential function. So we want to write this function out for capital F of x equals, well, we have 3 steps to writing an exponential function. First of all, what is c? What is the initial amount? So what's the y value is 0. For f of x, the y value is 0 is at 5.28. Our next step is what is our a value? What we're multiplying by, our growth factor is 2. I know it's growth because it's bigger than 1. And so my last step is f of x equals 5.28 times 2 to the x. Now if we switch gears and look at g of x, we're going to figure out, are we adding the same number so it's linear, or are we multiplying the same number so it's exponential? So I'm going to take the difference of these two consecutive numbers. I'm going to do 1 minus 0.5. And the difference is 0.5. So I add 0.5 to get from 0.5 to 1. What if I try to add 0.5 again? Does it work? Yeah, 1 plus 0.5 is 1.5. So I'm going to try it again. Plus 0.5. 1.5 plus 0.5 is 2. Plus 0.5 does get me 2.5. So this pattern is plus 0.5. So if we're adding 0.5, is that linear or exponential? Adding means linear. And now we want to write our function for g of x. Following our same steps for writing a linear function, we want to write our y equals mx plus b. Well, the first step is finding m, the slope, which is 0.5. Normally we would have to do y2 minus y1 over x2 minus x1. Well, we just do that. We figured out what are we adding each time. We said it's 0.5. Our second step is to find b. It's whatever the y value is with 0. So for this one, for g of x, the y value with 0 is 1.5. And then our last step is to write it as a function. So g of x equals mx plus b. 0.5x plus 1.5. If you're unsure of either of these answers, you can plug in a random x value. You could plug in 2 to each of these functions and make sure you get the correct y value out. So for instance, in that g of x, we just wrote 0.5 times 2 is 1, plus 1.5 is 2.5. And we could do the same thing with our f of x. plug in one of the x values and make sure we get the y value out. So if you plug in 2 to that one for x, you really do get 21.12 out for the y, so you know that you wrote the function correctly.